Hey, thanks for stopping by. In this video, let's take a quick look at the build process of a compact and high-powered LED grow light based on some of this cool white LED technology. So why do this? Well, if the constraints are to grow flowering and fruiting plants and vegetables indoors, I really couldn't find anything that was compact enough, didn't cost too much, or wasn't purple junk. My starting point or point of reference is this AeroGarden, which does pretty well, but we can do much better if we, say, double the amount of light in the same amount of space. So how did it do and what did the results look like? I think it's a success and the results speak for themselves. This chili plant has been growing indoors for the last 6 months and is on its second fruiting cycle. I've already harvested a bunch of pods the first time around and I'm gonna get a lot more this time as well. The other thing that it seems to work really well for is to power through these seedlings. Because of its compact size and high intensity, I'm able to pack these plants a lot closer than I would be able to otherwise and still get enough light to ensure fast growth. So let's get started. My intent for this video isn't to be a set of step-by-step instructions, but hopefully more of an inspiration or starting point for anybody who wanted to do something similar. Here's a quick look at our parts list. We're going to be using 6 CREE LEDs in 5000 Kelvin color temperature on an aluminum heatsink and power them with an LED driver. We're going to use some fans to cool the fixture, and we're going to use some 3D printed parts that are optional but add some functionality to the overall design. Now let's take a look at the components and some of the first few steps that we'd need to take. We're going to wire these up, as you can see, in 3 parallel sets of 2 LEDs each. And I've chosen to do it this way because I really don't want to deal with too much of a high DC voltage in this particular application. Now, ideally for high-powered LEDs, you do want to wire them up all in series, which ensures you have the same amount of current flowing through all of them, which really helps out on the thermal management side and also ensures you have uniform brightness across the whole length of the fixture. There's a couple of things that help us out in this situation though. One is that we're running these LEDs at a lower current than what they're rated for, which should help with the thermal effects. Also, we can check that the voltages for these LEDs are fairly matched so that in parallel they're drawing approximately the same amount of current. Okay, so moving on, there's a few more things we need to complete this fixture. We're going to be using a couple of 40mm fans connected in parallel and with their own external power supply. We're also going to be using these 5.5mm jacks to provide the required power inputs for the LED and the fans. And finally, these 3D printed parts will help with some protection for the fans and also provide the orifices into which the jacks can be attached and the power can be delivered to the fixture. Okay, so it looks like we've got everything in place. The fans are temporarily attached to the heatsink with some double-sided tape. We'll come back later and put some screws in there. And now it's just a matter of clipping our enclosure piece and fastening it with some screws. And you'll also notice that I have some eye bolts on either end to enable hanging of the fixture. Okay, so far so good. Now it's just a matter of cleaning up the LEDs before I power this baby up. I'm using some IPA with a Q-tip just to clean the surfaces of the LEDs. So there's a few more things we gotta check before we let this thing rip. One is the amount of current that's flowing through each of the parallel arms of the LEDs, and I expect this to be about 450 milliamps based on our calculations. Also, the heatsink shouldn't be getting too hot under steady state operation. We need to check that. And finally, what is the total amount of power that this fixture draws under steady state? It should be slightly over 52 watts based on the calculations. Surprising when things work out as planned.